part is about, I will give some introduction about machine learning, deep learning concept, and what kind of life circle, and also some basic models introduction. The second part is coming to the most common used tool for the data scientists, the Jupyter Notebook. They work with this to usually to handle the data and train the model. The last part is go through a lab with some predefined code, and then you can get some concept of what I covered in the previous session. Usually, we always heard about AI, machine learning, and deep learning. What's the relationship and timeline? It's like at the beginning, early as 1950s, there's a AI concept comes out, and later then machine learning comes out, and in recent years, deep learning is more and more used in our daily life. It's more like AI is the biggest concept, which includes machine learning, and machine learning includes deep learning. I have this picture copied from this blog. You can have more detailed information there. Then, what's machine learning? Machine learning actually, I think, is more like to first you discover some patterns from the existing data. It's like you find some rules, but sometimes the rule is not easier to identify by humans. So we need some model actually work as it's based on a mathematical statistic method to find out the pattern. And then when we find a pattern, then we can use the pattern to make prediction for the new data. It's more like that. And with deep learning, actually the patterns even not easier to identify by human. But in the machine learning domain, later I will show decision tree is more like a logic judgment, make a judgment about which branch to go. Then finally you can reach the final prediction. In real life, the machine learning actually will cover several circles. First, the user should get the data they think is related to this problem. Then they have they need to do the data preparation. And data preparation is more like put the data in the place. Then you just go through the data and try to find some relationship between the data, whether these have some correlation, how to handle the data, and then come to the data wrangling. That part is more like when we get the raw data, actually the data, some missing, we have some missing values. Not all the records is full fields ready. Some have missing data, and some have duplicate data, and also some data is not valid type. So we just do some data cleaning part in the data wrangling phase. Then we will base that to the data analyze and understand maybe which model will work for this problem with this data. Then we will select some. Maybe there are already some quite a lot of pre-trained models in the industry. It's very classic models. Then we can select model, one of the model, then use our data to train the model. Make the model is suitable for our use case. Then we can test the data, and later, if the data scientist has the model ready, how can make it as a service available all the time and guarantee the service standard. That's the deployment phase. Actually, I'm working on that phase in the daily work. Then come to what kind of machine learning algorithm we usually can find. These three types, actually from different aspects, there are different types. For example, online and offline, that means real-time prediction, or offline means you can have delay to predict the data. This is the common types from what the model need if we want to have this model. One is the supervised machine learning. That means usually you should have some data, some trained data. That means you have some existing data, you know that you have the data and also the, for example, like a classification problem, last course covered. We have some images, and you also put a label like this cat that is dog. That's the train, like the train model, the train data called have label inside. So supervised learning is must have the labeling data for training their models. And supervised learning is like you haven't trained you haven't labeled the data for training. You use the raw data to read, but later you will come out with a type of prediction. The other called reinforcement learning is what usually we have for like AlphaGo. It's about like when we don't know the rule. Actually, when the user acts one action, the agent here, then you got a reward or punishment. Then the agent will learn by by different tries and get the strategy by itself. This is the reinforced learning. And for supervised learning, we have the common usage like image classification, like Google Lens. We put a camera on something, then it will tell us what's the like a plant, what the plant is, what's the name of the plant, and also like for example, like we have the weather data of the whole year, then we can use it to train our model, then get a prediction for the next day, what the weather, like raining or sunny, we get that information. That is all based on supervised learning. And supervised learning is like when we have the for like Amazon or Walmart, they have some user data. Find this user always buy this kind of products, and another user has the similar characters like the age, the gender, and maybe the location. Then they predict that one also may like this kind of products. So they give the recommendation to the users. When they open the browser, always they can see the popular or recommendation product list there. That's called used for the unsupervised learning. Yeah, I'd also like try to give a quick introduction about the deep learning. Actually, deep learning is based on the machine learning. It's called deep because it has more layers and more steps, more parameters to give the prediction. It's more like it mimic the our neural network in our brain to help human body make a prediction or do a classification. That's the name comes from. So there's a lot of vector linear algebra related matrix computation in the deep learning domain. We have usually the deep learning models is like this structure, but you can see here like three layers, and in each layer they have specific number of nodes, like neurons, and also for different collections they have different weights. For the in the industry there are many classific models for deep learning. The differences is like how many layers in each layer, what's the sequence to put the layer by layer, and in each layer how many nodes, and what's the weight between the connections. That makes them different model to model. So when I try to summarize from my understanding about what's the difference about deep learning and machine learning, I think the labeling training data is usually also needed, but in the industry for image and NLP related domains, they already have a lot of trained data, public data set we can use. We don't need to do the labeling by ourselves. But if you do some specific problem you only face, like today the lab related things, we need to label the data, but for our usage. And here, and also no feature engineer needed. What's a feature engineer? I haven't maybe make it clear. Usually, when we have a data, it's not one dimension. It's several dimensions, several features, several dimensions. So we will judge which dimension data is needed for the model. Some maybe not needed. Some more maybe more important. So that's the feature engineering part steps. You should figure out the data which data are useful for this model. But for deep learning, you don't do that. You just put the raw data inside. They learn by train. They will omit some features. Some data not as features. Some are as features. And what's the weight? What's the different coefficient parameters put inside for each data? Another thing is the result of the model result is not easy to be scanned. For example, if there's a part of the image and the deep learning model shows that's a part of the dog. When you judge that, how the model make the prediction? Why they think this is a dog's head and not a cat head? What's the feature or what the factors make the model think this way? That's another domain need to be worked on to make the explanation more easier to understand. And actually, there are also a lot of industry well-trained model already available for the machine deep learning domain. Like for NLP models, there's a public. I like to share here. There's already a public hub. Actually, you just like a GitHub, you already can find a lot of models useful for your cases. You can find the task. What's your task? And then you can find the pre-trained model. Then you can use that model and use their sample code to find out. Like, let me show a translation model. You can find maybe this one. They give you a interface here. You can just try this model. See, it's loading. And also, if you want to use the model, you can also use the model in transformer. That code. This NLP model usually is very huge, so the competition will take some time. That's the deployment part. We're working on that. Usually, the companies will provide very powerful hardware to make it faster based on the user need. But it means a higher cost for that. We can continue. And also for image classification, that also one page showing the standard industry evolution for the models, and also there's a public evaluation of each model based on the very known public data set. And here I list two courses actually I think are very good. It's provided by Stanford. I learned both of them based on my need. So if you want to understand more about computation vision or the natural language, then you can go to the course, find out the related sections, and look on that. Oh, it's still loading, so it's quite low. Okay, here I also like to say, if you have a model, how can you tell the model is good or not? Whether what metrics you can use to judge your model. So usually I think there are three parts. First, if you want to compare your model with some other models, it's better you have use some public popular data set to to make as a input. So here, for image model, it's a very popular dataset called ImageNet. Actually, this is back. I always mention to Yuri about the name. It's a Chinese American famous film scientist. I think the most contribution she made is build the ImageNet dataset. It's a worldwide widely used dataset. And also the metrics, how to judge the model performance for the normal classification models. We can use the accuracy. Accuracy means the right or wrong. Because when you to test a model, you also have test data. For that test data, you also have a label already there. Then you can compare your prediction result, classification result with the existing label. Then to understand how about the percentage the model predict correct. For NLP model, actually is quite different. It needs some domain expertise to define some metrics. I used that before, but I can't remember very correctly about the details. But it's what I also discussed with Yuri before. She said, what's the usage for? I told her like something the image of how to generate some image following the masterpiece of the history masterpiece. She said that don't need art releasing knowledge. It's just a machine releasing. I'd like to show the example like NLP model. Actually, I know for Apple, they have some. I have a friend actually learned language releasing. She now working as a machine learning engineer. Yeah, she learned some engineering part, but her expertise is how to judge the language aspect. How about the model? So I think domain knowledge is also very important. Just Roy asked me for PayPal, what's the use case for the machine learning? That PayPal, it's for online payment, usually the fraud detection, whether this transaction is valid or not. It's very important. It relates to value loss. So we have a team called Risk. The team is handling this kind of detection. So they build their model mainly for that purpose. And also we have customer service department. They want their model to predict whether the customer will make a compliance based on their behavior before and the discussion before. So that's their models. And also we have some internal, for example, for our big team, there are a team who is provide a notebook to the whole company. That notebook is based on PayPal related logic and on-site. They also, because there are many questions asked frequently, repeatedly for some notebook usage. So they build a chatbot. That chatbot is answer the common asked questions. That also related notebook expertise. The chatbot should have some training data related to this usage. So domain knowledge is also very important for machine learning engineers and also data scientists. So that's I like some talk a little more about that. And also there are some results I can share. For example, this is you can see the curve. Actually, it's about the image classification model evolution from the early 2010 then to current date. You can see the classic models changed a lot. Actually, when I take the master course, I use VGG 16. I remember somewhere here. It's a VGG 19. VGG also have different variation for the models. I use the VGG 16. It had good performance, and also one of our team members use Inception V3. that's about 2019. We use that. Now you see the model already evolved to another some new I haven't tried before. And also here you can see the accuracy is increased continuously. Now it seems like come to a floor. So it's already 90% of accuracy. That's some result. I mean, here is like using the accuracy as the result evaluation. Well, accuracy is what I just taught. It's like a prediction classification result compared to the label, whether it's correct or not. Actually, there also have some different kind of metrics here. For the comparison, they use only the accuracy. Okay, next page. If we have the model, it's also actually in the daily real life, you need some hardware to run the model. When we have our local laptop, we usually have CPU on the inside, but some powerful ones, maybe mine, it also have one GPU card inside. It's used for the, usually training model is very time consuming. So training usually use GPU more frequently, but for serving, like I tried the NLP model on the Hugging Face model hub. It also needs GPU. It's very slow for the translation model to run. And so usually, if you have your model complexity increase, you should considering and multiple costs to that model, or you maybe change the GPU model, the GPU hardware to make it faster. And now, even in the industry, like Microsoft and also NVIDIA, they made some change to the, like they already have a model. Actually, for the model, they can provide like the graph, how the deep layers are and how the connections are. Then they based on that to make some computation optimization to make the model more efficient. So there are some current standard very powerful optimization like Onyx and TensorRT, this kind of hardware computation related optimization. I tried some model like I remember it's when I use Onyx, it's one half the time I needed to do the same inferencing. I mean same prediction. Usually when I use you use a typical one GPU card, it takes for example like 100 milliseconds to return the result. But when I switch to Onyx, it will return within 50 milliseconds. It's very you don't even to invest more powerful hardware. It's only change the data, the model format. It will improve the model performance, and some optimization actually will lower the accuracy. But Onyx change I tried is keep all the weight and changed. So it's only the computation-related optimization in the very low level, like hardware-related optimization. So it's no loss in the model accuracy. And here, when you want to try some model, you will find actually they have some predefined framework. Like the very currently the very popular one is PyTorch. It's provided by Facebook and Google. The TensorFlow. TensorFlow is more popular years ago, but PyTorch now is more prevalent in the industry. And in China, actually, Baidu also provide a Paddle framework. I tried that before. It's very powerful, but it's more like not compatible to PyTorch or TensorFlow. You should do, for some standard model, you should do many conversion between them. So in our, I think currently, if you want to try the PyTorch model, it will be easier. Though they are quite similar, but they have more support for more models. And I also provide some useful links. Then if you have interest, then you can go by yourself to learn the more knowledge, I think it explains more clear and detail about the things I touched here. For example, machine learning, there are different
I'm locking myself out.
And if you click inside, you can see more detail about each model, and also there will also have some sample code. So this step, and also there are this one is I like this is a very very classic book actually in machine learning domain, and it also have the code inside. It's a notebook based tutorial. You can do it by yourself, follow the steps, and you can have more understanding about the concept. And for deep learning, here here also I give this page showing current standard image classification models, and there I also already mentioned the Stanford course for the specific topic. If you want to do a project related to very specific topic, then you can go there to get more knowledge and understanding about that. Usually for us, we don't need to change the model. We just use a pre-trained model to do the transfer learning, use your data. But sometimes when you try to do something new, you need to understand the very detailed concept, and maybe you change by yourself, build your own model. That's the thing. Come to you read the I think Stanford tutorial about the model. It's a very in-depth understanding about how like convolutional network, the CNN models. How about the BERT models, transformer, this kind of models. Deep understanding about the model. Then you can make your change. And also I like to show if you have a model and you can make it run in local in your computer, but you want to do, sometimes you need to do a presentation to the teacher or someone to show your model performance. Then I find a very easy tool. Just need to write quite a few lines, then you can demo your model. For example, there's they have the demo like maybe it's a Euro model demo. What's Euro? Euro actually is like also a very popular model that will when you have a video, then it will dynamically identify the object of the model in the video. So here the user actually import their model in the code, then run some testing data, and here this code, this tool, the Streamlit simple tool will show the effect to the users. It also have many different demos. You can look at that. So whenever you need to demo your model, you can consider using some. Maybe there are also some other tools, but you don't need to understand or write the front-end code by yourself with many time. You just focus on your model part or your back-end part, then you can try some tools to make it easier to demo the effect. Oh, okay. That's all about first part. Any questions? Too much? Okay.
What's a model?
What's a model?
Yeah.
It's I think it's a mathematic. You can think it's a mathematical equation which can identify the data pattern. For example, linear regression. Let me show them. Talk about linear regression or logistic regression. It's linear regression is more like a multivariable equation. If we have, it's like that. If we have several variables, it's like called a feature. And you train the model, you get what's the weight of each variable. Then if you have a new data, you just input the variables. Then you can calculate the result. Based on result, you know, for example, I just mentioned the weather prediction or house price prediction. You have different data, like for house price, you have zip code, you have the house bedroom number, bathroom number, and also like two shopping mall distance, this kind of like a variable. This is variable. And then you already have an equation trained. You know for each variable how much the weight, what's the weight for this variable. Then you calculate a result as price. That's this is called a model. For deep learning, the model is more like a lot of matrix computation. You don't know actually why this layer is should be like put like this many number of nodes. Why the weights are there? It's not understandable, but it's as a whole, it's a model. Yuri, do you have any question? I think you just tell me something you don't talk or something. Any question? She think I talk too much. It's hard to understand. Okay. Also, let's come to the Jupyter Notebook. Jupyter Notebook actually is this page showing how to install it and then how to start it. Today, for each Raspberry Pi, Eurostat already pre-install something, so you can just go to the IP and open it. Then you can run the code. Yeah. Is that they put the in each table there are paper showing the IP. So I actually talk about what's the Jupyter. Jupyter actually is a very popular. I think for the data science, they work with Jupyter Notebook every day. It's more like if you have a PyCharm or like some other IDE in your notebook, in your laptop, usually you put the code there. But for data scientists, it's hard for, I find it's hard for them to set up the environment. So Jupyter Notebook is like a pre-set up environment. Already install the OS related things, library related things, then the user only need to type in their code there. And also Jupyter Notebook can run by line. If you put one line and enter, then you can have the results shown there. And the Jupyter Notebook also have very powerful visualization tools, libraries. It will show the results very easily for the user. But Jupyter Notebook actually have several parts. One the kernel and the other server. This is in the backend. For the user, they usually say the browser. Kernel means where the Python installed, where the library installed. You can, for user, you can predefine several kernels. For then every time when you open the notebook, you select one kernel based on your need. That means different user can have different kernel based on their library requirements and also hardware requirements. For example, some users need GPU, some users don't need GPU. Then you can build different kernels for them. When they don't need GPU, then you use CPU kernel. It makes the costs lower for them. But some users, they need GPU. Then every time when they run the heavy competitive models, they select GPU. That's an overview about the Jupyter Notebook. It's when you just open it in your web browser, input the IP, then it will turn up, and then you can also have markdown and also text like the comments in the notebook, and then you have your code there, and they can also use some library to show the image very good. Then it's easier for you to understand your data. And also Jupyter Notebook is not only support Python, it also support R, I remember, also Julia and other some new languages. And this is the kernel. Here you can select the kernel here. If you have multiple kernels, you can select here by clicker that get the options. And here I also want to show if you haven't installed the Jupyter Notebook, you can also use the Google Colab. It's quite similar, and also Google Colab provide free GPU usage. I remember I already opened one. Okay. This is Google Colab. You can see the style is quite similar. Like you can write the code, and then you can show the visualization here. And the only difference here is this step. Almost finished. Here you can see the quite similar this is a Jupyter Notebook. It's a run for me. I installed it Jupyter Notebook on my local machine, so it's open from my local host. And here is the file, or the data file, or your code file here. Then you run the code in this part. For Google Colab, actually you can have similar things here. But I like to mention the Google Colab also have some. The good thing is it's online. It's easier to share. You just send the link to others, then they can open it. And for Jupyter Notebook, you also can share. But if the server is in your local machine, it's hard to share. You just download the code and share to others. You can't share by a link. And the other things, it's also integrated with Google, a lot of Google related products like Google Drive. You can share the data in the Google Drive, and then you load the data from Google Drive. Here, when you want to load the data from Google Drive, you need to mount the Google Drive as a dictionary volume to your Google Colab. Then you can mount, you get the data. And the best thing I'm saying is like when I use that before, I train a model. It's a computational vision model. That's a very huge model. So when I train, it needs time to finish the job. Then it train. When I train, if I don't, sit beside the computer, I need to always make it live. Maybe it take 1 hour to finish the training. So I leave my computer for other jobs. Then when I back, it's broken in the running. So the previous run tabs lost. The data is lost. It can't be kept in somewhere. You need to rerun all the things. So later I will find some some hack way to make sending a live heartbeat to the server to make it think we are already there. But for the local machine running, there's no such problem. And also I remember the data mount to the Google Drive also always lost. Every time when you run the notebook, you should remount the driver. That also involves some password input, some kind of activities. I think sometimes I feel I really feel I want to have a GPU in my local machine. I don't want to every time connect to that. But if you want, you try something new and don't want to pay for it, then just use Google Colab. I think it's can meet a lot of work requirements you want. And here is some Python library for data analysis. Pandas is for data frame. It's more like read the CSV files into a data frame. Then you can make it easier to handling. I think you really have a lot of experience. She smiled a lot on this part. Okay, and NumPy is more like mathematical computation related things like matrix computation. It's very fast and easy. And here is SciPy. SciPy is like when you calculate a mean, standard deviation, this kind of, they already have a very powerful embedded method for this library. If you install this library, you can easily use that statistic related concept. You just write like you write in your home math homework. You write the keywords, it can work for you. You don't need to implement the calculation by yourselves. The matplotlib is for the visualization. We will show that in our lab. Scikit-learn it's provide the standard machine learning models. You can just import, and also it has some matrix library already there. You can use it. The Simber is also a visualization. It's a visualization for the statistical models, and I tried that before, but now I haven't used it anymore. But before, when I want to calculate like the Q value and also the standard deviation and also showing IPR, this kind of maps concept, I use that. And the other two actually I'm not using quite long, but for NLP models, you need to use it. So when you want to try some machine learning algorithm, where to find the data to practice? Here I list some, you can use it. I remember for yours that someday he found some data, he is excited, said, I found this data set is good. I found it's UCI data set, it's a very famous data set. But here I like to recommend more about Kaggle. Kaggle actually is, I think it's a very good when you learn machine learning. They have data set. Also, they have a lot of computation. You can pick up a topic and try to build your own model. Then you can join the computation. That rank is also very useful when you want to find a job or something. You can, if you rank high enough, you can send. And also there, I remember there's annually some big competition that has a high price for you. You can get like a couple thousands dollars if you can get the first prize. And also you can see even for the same competition, it will show others' work. You can go inside and look why they perform better. Then you can learn from that. You can see that there's the competition. Yeah. So I think if any of you are interested in the machine learning and think want to earn some money, then you have time. Then you can work on it. It's not the deadline usually is long enough. You can have time accumulate your work. Then someday maybe you can get some prize.
Okay.
Yeah. But I know there are very good experts on that in the competition. So you can practice by one, then maybe someday you can reach something. And okay, we come to the last part is the lab. For the background of the lab is like you instead install some sensor on top of our one of the in the hallway. It's not here. Then every time when we go through there, it measures the distance from us to the sensor, and it kept sampling the data. So if I go through the hallway, then there are several data points connected. Then later he wants to say if we don't know. Actually, here when you run, the sensor don't tell you who is coming or who is go. Then he wants have a data to say who is coming today from the hallway several times. Then that's the problem. He just tried us to try this one, and she told me we can use this as an example. He make the train data. That means he make the labeling for the raw data and also do some data wrangling already. When I have this question, then I try this data use some very simple classic models. It can classify very with high accuracy. So I think the data quality is very good. So for machine learning, data quality is very, very important. One word called like garbage in, garbage out. It means if you haven't make your data good, then the model train out result is just a garbage. So I think for this level, Eurostat put all effort to do the data part. So for me, the model is, I haven't do anything specific. I just try the model, it works very good. So in the lab, it will cover, first I will show what the code running on the notebook. I remember last session, they already covered the notebook. Here I maybe add some explanation about that. And then I will show the steps, like I show the machine learning life cycle part. Then let's go to the code. He said I first go through my code, then later everyone have the Raspberry Pi that they already have the Jupyter Notebook installed, and you connect to that and using the IP in your own laptop. You already have the data also there. Then just run the code, get some feelings. Okay, let me show the line. Okay. Then Yuri proposed we go along together, so you can open your laptop to connect to the Jupyter the Raspberry Pi. There's a paper showing the IP of your Raspberry Pi. You can. Every paper is different. It's called height or what's the height? Let me see. Did you open it? Use this one. 你只要是 IP 就可以了。No need to log in, just IP. Oh, everyone, you just open the IP. I don't think you
put the IP in your browser.
Yeah, in the browser, in the I don't know.
Yeah.
Let me share.
It's not useful SSL.
什么？192.168.1.18888好像是。
I don't have Jupyter Lab installed or like.
888. Okay. Yeah. The password is
You just
I wasn't here last
just
week.
the rest API.
HTTP one
Go through
IP
this guy.
IP 是这个192.168这个，你就敲 HTTP， 然后后面空格是8888，就是还有个冒号888是 host。It's running, okay? What's the problem? Let's see.
The server is running. Did I go?
来，少帅，你把你这个给我，你把你这个 IP 给我，我给大家 demo 来，把你这个 IP 给我。哦，好了。密码是8888。
啊，进去了。
多少来着？是这个吗？刘
那然后 slash
lab 对。大家可以看一下我的，如果 IP 的话，看这个。Yeah, IP 在888在 lab。
Did you connect local network?
啊。
你现在 connect 到 WiFi。
到这个5G，不让过5G，到这个，你们得先 connect 到这个。
Local network, yeah.
这个。
Local 5G. This is important.
要先连到这个 IP WiFi。
I don't understand how my brother survives living on.
他说12356
这个
哦，你说这个 WiFi 的
？WiFi 的密码邵瑞。密码是啥
？WiFi
我不知道。
邵优瑞071，不是这个，不是这个，是这个5G 的是邵优瑞071，我给写一下啊。Let me tap， 密码是这个。
没有大写。
有的好像。
I don't know.
是这个。
Oh, I can
这
share.
WiFi 的密码是这个，你可以 share 吗？
Yeah, because I have my contacts.
这 Uber 的这 Uber 的生日是2007年1月份。
不是是。
Yeah, no.
不是，他是7月12号的，然后爸爸设计给7号。
不能放同一天。
这个可以登进去吗 ？WiFi？
要放进去。捡个 hint 是个 hint 是吧？
你先要登到那个 G 的那个 WiFi 有吗 ？WiFi。哦，对，你已经登进去了。
出去吗？
你是用这个密码吗？还是你以前就登进去？哦，那好。
去参背面那个。
那个什么湖是吧？蒙罗的马老师再往下。
B社。
攀岩去。那不是下雪吗？真要下雪。
What is the one in? Oh, that's because me. I'm.
大家如果都登进去就跟我说一下哈，然后就到那个 notebook。
This is 2 weeks ago. Oh, this is a whole
Oh
month
yeah,
ago.
there's a time stamp. You guys should see me.
10 weeks ago。
This is a whole month ago.
大家都登进去了吗？密码是这个 Jupyter Notebook 的密码是1234578。
我来看看每个人都登了，这3个都哦，只有 Caroline 没登录。Karen 登录。
你给大家看一下这个。
你要几天连？
好。
有 WiFi 点
Where's the stuff at? On my
OK， 然后呢？你
他
这纸
这个 IP。
还有。
那12点那个8点。
下面这个。
Why is this a month ago?
然后后面有说888。
对。
Oh, it's up at 11.
你要不就 wait。 不是，你就登我这个吧，可以我这个我这个秀出来的这个 IP， 我也不知道它这个，就这个可以看看。这个是1.228888 lab。
Oh, that's right. Why am I 11:30?
你去过了。
好了吗？还不行。
他编错。
不是那个小朋友的怎么连不通？哦，我看一下啊。
那个标那个
Lab.
No, it's because I don't ever get up at 6:30. Oh wait, no. No, yeah, I don't get up.
OK，继续。
进去了啊，好，那我们就到，你们俩也进去了哈。OK， 我们到那个 notebook。notebook 的话，这个 notebook 的第一步呢，就是说，
That was the one day I was up at 6:30.
就是说我们要去 run 一个 notebook 的时候，你说我现在呢用到了这几个 library， Python， 还有什么 NumPy， 还有这个 Matplotlib， 还有 scikit-learn 啊，这几个 lib 就是说 lib 你先要装一下的。就我当时是做了一个，就是比如说我做了一个叫 requirement TNT， 就是说TXT， 就是说以后你去 write Python code， 我想你们可能都有这些经验，就是你要把你的 library 先写在这儿，然后你再用这个我 pip install -r 这个 requirement TNT， 它就会把所有的给你装好，就这里面你列的这个 library 全装好，就不用一个个装了。装完之后呢，就是你现在就是你这个先得把这个 library 装上，然后有些 library 它是embedding， 就是你装 Python 它自动就带的，但是有一些是没有的，就是你要如果没有的你就要自己装一下。装完之后呢，在开始之前我们就先要这个 library import 进来，然后呢这个 scikit-learn 这个地方大家就可以看到有很多个 import， 因为 scikit-learn 它提供了非常，就这个就是我 scikit-learn 我这个地方给大家刚才想说的，它是一个非常powerful， 它除了提供 library， 它还提供了一些就是说怎么去评价一个 library， 除了提供model， 还提供了一些就是说评价 model 标准的那个 metrics， 还有一些打 score 的这些图，你都可以直接用它，它自己也有一些 visualization 相关的事情。所以我这个地方呢有很多那个我看 import 这个 scikit-learn 这个 metrics， 你看 confusion metrics 它就是做一个能把你的 predict 和你原来的 label 的数据进行对比的。
哪里错了，哪个弄错了，这个就它会打成一个 matrix， 非常容易看明白，就是你错在哪。然后呢，这个是 model selection， 这个地方呢，就是说我们去做一个 model training 的时候，比如说我现在这个 Jupyter 给我提供了200个 data， 那这个200个 data 呢，我需要拿一部分去做 training， 还有一部分来做验证，就是说我这个 training model 它的结果怎么样，就我把它做成 test data。然后它这个 scikit-learn 也提供了一个 train test data 的 split， 你只要它默认是有个比例，你输一个，比如说0.7，它就说70%是 training， 30%留给你做这个 test。然后它这个 split 的时候，它也会有一些就是 random 在里面，就是有一些算法让你这个 data 分的比较均匀，不会说你正好 train 的 data 跟那个 test data 会有一些就是大家实际上是有一些那个 drift 的，就是你 train 出来 model 跟你的 test data 不 match 这种情况。然后剩下这个就是具体到就是 model 了，比如说我这个里面用了 decision tree 这个 model， 还有这个 KN model， 就是刚才讲的这个，在这个地方有稍微提到，它们都是一些比较常见的 model， 就是这个这叫 K nearest label， 还有这个 decision tree。decision tree 之上还有一个叫 random forest， 这个 model 呢其实是 decision 的一个 example， 就是它会有很多个 decision tree， 然后再去做这个它们联合判定，就比如说每个 tree 我判说这个是个狗，这个是个猫，那10个里面有9个都判的是狗，那它们 example 一下就变成一个狗，另外一个就是忽略掉。它的好处就是说它会，因为我们的 example 越多，这个从这个概率的角度来说，它会比较 performance 更好。然后它这个每个 tree 它其实只是拿了 random 一部分 data 去做的，所以保证这个 data 打得够散，就是这个能让这个 model performance 更稳定。然后呢，这个再回到这个地方来，就是这些引炮的部分啊，这个还稍微重复了 ，sorry， 主要是。然后第二步就是我们先把 data 读进来，这个 data 呢，我也想给大家看一下，这就是优爸爸已经把它做成了一个，这是他自己做的一个打的那个标签，然后这是他自己做的一个标记，他就说，比如说这是一个个采样点啊，采购的结果，这是采的时间，这个结果其实有点像是我们到它的 sensor 的一个距离，这个值，然后呢，他自己还做了一个 match， 说这一段数据都是一个人的，就是他自己当时就是，所以他的 data 做的已经很多了，就说首先他说这是他走过去的，而且这一段数据都属于这一个人，不是说就是说，因为原始 data 可都是没有这一行和没有这一个 column 和这个 column， 只有这个时间和这个距离，那他要去识别说这是这个一个人做的。然后呢，那天晚上我们去做的时候，就是 training model 的时候出来的时候，结果有点奇怪，就是我和他的身高因为比较接近，所以我们俩称出来是，有时候我们会错，但是其他几个人就是弟弟的是最容易识别的，他跟别人差别很大。然后后来他就觉得这个很苦恼，我说这样你再走几遍，就是你再走几遍，我们增加这个 train 的准确性，因为他以前也是根据记忆，有一些并不是实时去打的 label。我说那你现在走几遍，这几遍肯定都是你的，然后我再走几遍，然后那样就是保证这个我们的 label 打的准确，就是现在就是抹生根这个领域呢，就是还有一些创业公司，包括以前我们前段时间有一个华人的公司，他其实做的就是做 data labeling 的，那个公司是一个亚裔的小男孩。
是 MIT 里毕业的。我
忘记，对，就是他就做的挺大，他就是给这个各个大公司的 train model 这些人，好像是提供 data， 对。然后他可能他们要做的说这个打 data label 这事儿，像以前那个 ImageNet， 他就是外包给很多就是大学生啊，就是大家去做这事儿，这都涉及很多人工的投入。那如果有一些高效的，就是他们可能还是有一些人工的部分，但是也有一些可能是可以用算法去做的，那就更好。那这部分就是，他就打了这些 data， 打完之后，这就给大家先看看，大概就是这样一个 Excel 表 ，CSV 的文件。然后呢，我这个地方呢就用到 data frame， 这个 data frame 有 Pandas 的 data frame， 把它读进来之后呢，它就会帮你，你看我做了一个事，就说我现在读了这个文件，同时我给它这些，这几个 column 起了个名字，它就像一个 feature name， 就是我们刚才讲的 feature， 就是说，也就像一个 variable 的名字，这个 variable 叫什么？我这个这个叫 sequence， 这个叫 time， 然后这个 distance， 这个叫 name。那么我把它读进来，大概有这么多行，就是6000多行哈，然后有四个 column， 就代表4个变量。那我们知道，其实我们要做的是把这个 name 这个当成一个 predict 结果。前面呢是我可以前面3行， 就如果我后面想做一个测试的话，我提供的数据就是前面3行，那么我希望得到结果就是说，判断是谁，就这个事情。然后这就是 data， 你看 notebook 的一个好处就是说，你比如说我像这一行，我把它读完之后，我做了一个第一件事，我先把这就是 data cleaning 的部分。然后有一些数据是空的，这个如果是一个斜线，之前我们读出来这个数据是有问题的斜线，那我就把它变成一个空值。然后呢，我再把空值 drop 掉，就这一行我整个就不要了，发现这数据有问题的我就不要了，这样保证我拿进来 train model 的 data 是好的。就刚才说 garbage in garbage out 的问题，就是你如果一些乱七八糟的东西，那 model 它是不能识别的，它就给你按照它这个逻辑去算了一遍，你这个错误的 data 也在里面对这 model 起了不好的作用。然后下一步呢，我就去看一下这个到底有多少个 data 呀？然后如果我把这个 sequence， 因为这个一个 sequence， 比如说我刚才受的这个，这个比如说这都打11的，其实它是同一个人的，我需要自己要把这个数据做些处理，那我就去先做了一下，我根据 sequence 做 group NA 的话，就是我把这一个 sequence 的都把它标成一个人的，叫 group， 这就是涉及到了这个 data frame 的它的一些 method， 这些都是内嵌的，你如果用好了，很多都不需要你去写，你只要去用它的这个写好的东西，它会很快帮你出结果。然后我就想看，那我这里实际上有多少个 sequence 呢？我这样算下来只有275个，虽然有6000多行，但实际上是只有275组数据，可以这样理解。然后呢，我再看一下，那这个sequence 里整个里面最低的就是最低的那个，我看了一下，就说每个人都有谁，就是属于我的有33组。然后这个地方为什么要做这个事情呢？因为如果 data 就是特别不 balance， 就是一个人的数据特别多，一个人数据特别少，那么这个 model 可能训出来是不准确的。所以我们在 machine learning 那个里面，它还有一部分叫 imbalance data 的 handling， 这部分也是 data 处理的一步，就是在真正 train model 之前你要做这个。它的做法的时候呢，就是比如说我可以把这个最多的 data， 我发现它太多，别人都比较稳定，那我可以做些 sample， 我取掉一些，只取一部分数据出来，或者说我有一个 up sampling， 就把这个数据少的我去做一些填充，做一些用那个数学的方法把它 sample 就加一些东西进去，加一些 data 进去，让大家的 data set 比较 balance。就我们经常出现那个就是说 data set 特别不 balance 的 case， 就是说比如说fraud detection 就是因为大部分的 transaction 都是正确的，都是对的，只有 fraud 只有一部分，就是只有很少，但是这个 fraud 这部分就往往是最关键的，所以在这种 data set 里面是需要有一些额外的处理的。然后这个当时呢，我就又把 sequence 和 name 做了一下，然后去算了一下这个大概速度是当时是我看一下我这个 speed 是从哪来的 ？speed 是我算出来的，因为我之前没有这个叫 speed 的这个变量，我自己又进行了一个处理。我看 speed 就是说，我把时间去掉，然后呢把这个整个 group 了一下，按照就是这个 sequence 下，同时是属于这个人的，算了一下，然后去算说，那平均下来我的 speed 是这么多，然后我们可以看到每个人的这个其实叫 speed 可能也不是特别准，但是我就可以看出大家的 data 的一个关系，就像刚刚讲的，就是弟弟的数据是最那个最小的，所以它很容易就识别出来。这就是相当于说你在做 model 之前，你先对 data 做各个方面的一个评估，你大概心里先有一些 idea， 然后你才能选说什么样的 model 我可能可以用 feature， 用啥东西做 feature， 然后什么样的 model 可能适合它。我当时做完之后就可以很明显看到说，那弟弟的数据是最好识别的，那我跟爸爸的数据就是非常接近，那我们需要可能还要看看有没有其他的维度可以加进来。然后呢，这部分想受的说，这都是 data frame 的一些功能，它可以帮你做一些这个，怎么说呢？就是你把这个 data 做各种组合排列去受，然后再下一步呢，我就这个地方想受的就是这个 visualization 部分，就 matplotlib 这个 library， 我们可以拿它去画很多东西的，我可以把它画出来，然后你这样看东西你就会很直观，你就可以看到说这个按照时间分配，这个distance 是这样的，然后呢 speed 是这样。其实 如果我们把这个时间维度再加进来，有可能也能加进一个，就是说一般白天弟弟肯定不在家，悠悠肯定不在家，是吧？那就剩下这两个数据就可能只是这个，就是这也是一个维度。所以你要先看到原始数据，你大概从逻辑上去想想，你要把这个数据先用一种你自己可以看清楚的方式展示给自己，然后呢，再从逻辑上去想这些数据可能是怎么用。这样的话，你在选 model 的时候，你就会，就是你选的 model 就更容易命中你的这个问题。然后这个地方又做了一些 data 的那个data 的那个 visualization， 然后后来呢这部分就去做这个 data 的这个split， 刚才讲就是说这是一个 scikit-learn 它本身就已经实现了一个方法，你只要用它把这个 data 分一下，然后还有一些 random 的信息在里面。这个地方我没有，它可以填 ratio， 就是说你希望 train data 多少 ，test data 多少，我这个地方就没有填，然后默认它70%是 train data。然后它分完了，我看了一下啊，2个分的大概是这么多。那么我就选了个 model， 这个 model 就非常简单了，就选一个 decision tree 的 model。decision tree 的 model 呢，这个 model 就是它的逻辑说，我先从根节点进来，我先判断一个条件，然后判断一个条件，把它分成两边。我可以在这儿稍微给大家看一下，就是它是一个非常符合我们人类思考的那个逻辑的方法。看一下啊。它这个还没有惯例，那就我就来讲啊，就说 decision tree， 比如说我们现在呢，我们有只有很小的那个数据，就只有一个 distance 和一个那个，其实就只有一个这个 distance 的这个数据，然后但是又有 distance 在变化的一个数据，就是它有个最低点和最高，就是最近最小的，最近的最短的那个值，就是我和那个第三次的最小的那个值，其实是一个比较可以跟 height 相关联的一个信息。那我当时就做了就这样的考虑。那么它这个就是说 decision tree 第一步先判断说，我举个什么例子会更清楚呢？可能这个 case 呢 feature 特别少，不太好举。我举一个例子，比如说银行它会去判断说一个人下个月会不会还信用卡，举个例子，这个问题哈。那么这个一个人的数据它包括什么？他的年龄，包括他前一个月还了没还，他的额度是多少，这些信息是吧？然后他的是男性、女性，是单身还是有 family 的？因为这些都会影响他的。假设这几个因素，那我先第一个进来说啊，他是单身就马上进入了另外一个判断，因为 family 可能他还的是以前的 model 它是更容易还的，那单 single 的可能是 risk 高的。然后就往下走2分，然后到了下一支，就比如说下一支我说我这是个 single 的，那他会判断他男的还是女的，男的又是进入下个分支，就然后比如说男的说，然后说他年龄是多少，你看是大学生还是说是工薪阶层的年龄，对吧？然后再往下走，就一步最后的结果就是他还还是不还，然后这个 model 就这样，他每个数据都这么走过之后，他顺出来了，就知道说新来个数据我该走到哪边去。最后它就会得到一个结果，这是 decision tree 的一个原理，这个就非常像我们平常的那个思考的那个逻辑哈。decision tree 你看这个就是非常简单，你只要把这个 scikit-learn 这个 import 进来，然后你把你的 train data 放进去，这叫 fit 部分就就是 train 这个 model， 然后 train 完之后呢，然后你把你 train 的 model 再输入你的测试数据，你测一下，那结果就给你出来了，说这个 predict 结果是什么。那我现在呢做了一个叫 configuration matrix， 就是说把测试的结果，这个是我原来的 label 的 data， 就是我拿来做测试数据，但是我也打了 label， 知道它是谁。然后还有这个是我判断的结果，那把它画出来说，你看啊，这个 predict 出来说这个是我，这是弟弟，这是爸爸，这是悠悠，然后这个地方是实际当时打的 label 是什么？那我们可以看到说，全部正确，就是谁就是谁了，这个 model 非常 easy。那我是觉得这个 data 确实特别好，就是有时候你不会这么精准的，还是会有错，有错的时候你就要去对 model 进行调整。这就是打一下去，大家都正确，全部都对，就是这样，这是一个非常经典 decision tree 的 model。然后呢，如果你是在去一种 random forest 啊或什么的 model 的话，你也是直接从 scikit-learn 就可以 import 这个 model， 然后再去做。然后但是不同的 model 它可能有些不同的参数，这个参数怎么设？比如说这个 max dips 就是分几层，就是你不可能所有的 feature 一层一层往下分 分到最后就是特别深这个数，那可能就便利了，就实际上是失去了效果。那我这个 math tips 就说这个 tree 只有2层，然后同时呢，这个 descent tree 它的原理其实是用的那个叫，我有点想不到英文怎么讲，就是熵，我们那个新兴论的熵的那个概念，它算那个熵，就是说不确定性值这个值越小，就是证明这个判定越准确，就算哪一条路径下来，这个熵是最合适的，因为它每走一步，它实际上是有一个 weight 的，就是你分到哪个 branch，这个 weight 是怎么分的，它这个 weight 计算的最终的判定原则就是以这个熵最小来做原则的，叫 entropy 那个词，你们估计我不知道你们会不会讲，后面会学这个吗？就统计啊什么 statistics 这个，现在还没有学还是学了都不知道。
Entropy is a temperature thing.
No, I mean it's a general.
In chemistry. No.
Well, we're not really a chemistry.
Look.
对，好像是有可能，化学学过吗？我
对，
记得。
化学意思是 temperature。
哦，那不是 temperature， 它就是有点像一个信息论的那个分析东西。我现在，当然我们当时我是大学学的这些东西啊，你们但是觉得你们现在学的东西都比较少。另外一个还试了一个 model 叫 KN 的 model， 这 KN model 其实就是说它跟那个这个 model 我其实觉得没有 descent tree 那么容易判断啊，就是你先自己定义说我有要分多少个维度，然后多少个 neighbor， 然后去设置不同 neighbor 去便利一下，看跑出多少个，它就是一个比较好的这个 key 呢决定了就是说这个运算时间有多复杂，但是不是说这个随着 key 越增加它就越增加，有时候它的曲线是一个先上升再下降的那个点，那你找的那个 key 或者先上升到一个点就平了，你找的这个 key 就拐点的这个地方turning point 这个点，这个 key 你就可以拿来做你的 model。这个呢，我就直接用了它这个 model 跑了一下，然后呢去算说那其实实际上这个 key neighbor 等于差不多到2的时候它就挺高的了，然后就去选定这个 key 是2的时候的这个 KN model， 然后因为这个 model 你先需要找到这个参数，然后找到这个参数之后你就用它去train你的 data， train完之后你再做 predict， 这个结果出来就是画了一个它这个它就要差一些，比如说。很多次他把那个比如说把 Yuri 拼成我了，或者说还有一次把 Y 也算成我，他的那个 accuracy 就会低 ，accuracy 就是这叫我们看一个 control matrix 的时候，它其实也涉及到叫false positive 和什么false negative 这些概念，但是它们统一的一个算的错就是一个 accuracy。但是在有些 model， 这个 false positive 或者 false negative 它是有意义的。就在我们现在这个 case 里面，我们只用算 accuracy， 就是说你比如说这个里面我们现在有多少个数据？200，我看我们有69个数据，那我们错了5个，它的 accuracy 就是64除69，就这样一个比例了。但是像刚才那个就是descent tree 就是100%全部正确。这就是受2个 model， 这就是说我们在做一个machine learning 的一个问题处理一个问题的时候，你首先要处理 data， 同时呢，你可能不是一开始就选中了最合适的 model， 你可能要多试几个 model， 然后找到最合适的 model。有些时候还要做 ensemble， 就是我把这几个 model 的结果用 ensemble 的方法把它结合起来。那又得到一个新的 model， 这就是你的 model， 然后你最后再拿这个最终的 model 去作用于你实际的 data 去做 predict， 这样就比较准确。我都已经讲完了，你们有啥问题吗？或者要 try 一下？
我有一个问题。
你说。
如果现在是4个人，如果来到第5个人，这个 model 可以自己再增添那个第5个人的信息。
你如果说你来第5个人，然后你这个 data 都没有了是吧？它必然会把你判定成为其中一个人。所以你要这个第5个人来，你一定要增加他的 data 再去 train 一下。
要重新 train。
对，要重新 train。
有没有其他的 model 让自己认为觉得这儿有一个跟前4个完全不一样的？
那我觉得这个就不是这个叫 supervised learning 了，这有点像那个 unsupervised learning 那种，你就不加就像它其实是 supervised 和 unsupervised 中间还叫 semi supervised learning， 就有点这样的概念。对，但实际上我在生活中没有，就是或者说我在工作中没有遇到这样的 case， 我遇到的更多都是有 label 的，就是所以每个领域它的那个，我觉得那些 data science 的关键工作就在做这个 training 部分，他们也不会发明一个新 model， 更多是用业界那些经典 model， 用于他们的 data 去做那个 transfer learning， 然后再去做 fine tune 去用。
那比如说现在的这种所谓人脸识别比较多的，那他不可能每个人都在 database 里。
你想想我们这个哈去做人脸识别，你要转很多次的，这其实就是一个 train 的过程。
这个简单它是直接一个是或者不是嘛？
对。
比如说像车站码头那种，它要识别出哪一个人，或者门禁系统，它要识别很多的话。
我觉得他们实际上是有，如果是门禁系统，不可能是完全没有数据的，它肯定是有这个人数据的。然后车站码头，比如说我们抓一个通缉犯这种是吧？像演唱会的那种，我相信它后面也是有数据库的，就是有这个人的照片的。
就是我焦点就是它这个 model 自己会不会发现这有个东西它不认识，然后它根据这个不认识再建立一个新的 model， 新的数据点。
你可以弄一个 category 说就是没有称过的人，他就把那个归到那一类就好。
那他会不会用这个在自己建立一个新的数据点呢？
会，但是你要把如果是谁，你还是要再给这人再打 label。
还是需要人来干预一下。
我觉得就是说，可能那个新的打 label 算法也许有那个，但是你必须得有一个能跟它匹配的一个东西啊，对吧？你就想象一下，这个演唱会不是说以前有新闻说演唱会抓到罪犯那种，就是那我相信他也有罪犯的。
他肯定有，他肯定有。
肯定有这个 data， 这个现在人工智能估计还是 supervised 的更多，因为它是
不能说这个人长得像，对，像有罪犯的潜质。
对他可能没有这个提取说罪犯特征的。
还是 predict 这个潜质。
你们可以，我觉得可以 run 一下，可以改一改。试试，其实如果要试过这个，我是觉得这个，比如说像这个画图的这个 library 其实是特别 powerful 的，可以画出各种各样的图。如果你查一下，你也能找到一些 example。我看一下，我找一下我有没有以前。
Have you not seen the Mid-Journey server, bro? There's like 5.5 million people in that.
Why is that?
You're mid.
什么东西？你看我们当时呢，我当时做了一个，我看看啊，就当时我们做了一个那个 project， 就说，他的老师要求是说是你看啊，我这个葡萄园，他跟葡萄园合作，说这个要帮葡萄园主识别说那个叶子上有哪些虫害，就是哪几种病。然后呢，你要告诉我，然后这个他把这个卖给那个葡萄园主啊，那就根据这个他可以去下药吧，我觉得去可能打药。那我们当时呢，你看我们要去采集这个样点，就我们当时从 Google 上 search 了很多 model， 你这个很多那个图片，然后你去打 label， 这个就是我们的工作的一部分，就是你现在在 train 之前你自己做了很多，然后当时那个 data 其实比较少，又做一些叫 augmentation 的，就把这个 data 做各种变化的，旋转呀，对称折叠呀，然后还有一些就是拉伸啊，就让这个图更多，这个会影响一定的 accuracy， 但是实际上会对你 data point 的增加还是很帮助。然后我看看这个，我们当时做出来的这个准确率非常高，我觉得挺神的，就是看一下这个，看一下现在，你看这个。Final report， 当时就这个是一个一个 paper， 我看可能是这个地方讲的这个 Visual 16的这个 model， 然后我觉得还有一个比较好的，我们当时做了一个 visualization， 就是说 CNN model 每一层我怎么把它秀出来，这就是说它一层层的变化的时候，它其实是在做一些 pattern 识别的，这是叫。你看， 因为它在里面这个 convolution network 实际上有一些 activation 啊，还有一些这个一些激活计算，这个每一层有些 pooling， 这个不同的计算，我在这一层上打，我看这是一个原始的图片，然后在每一层的处理上，它就会已经有这么多种变化了。然后这就是使得我为什么认为这个是这个，就是能判定是某一 class 的一个原因。这是为了让大家看它的，就是理解这个 model， 就比如说我能打出一个病灶的点，这是我这个 model 怎么判定说我为什么我这个 model 是做出来是这个。它是在哪些点识别了哪些特征，然后这就是做一些这个visualization 的事情。这个当时我们也是准确率非常高，我看一下。accuracy 这还有个 FE score，FE score 就刚才涉及到那些。计算，这些实际上是你们数学上后面会用到的一些概念，啊，这是不同的 model， 这是自己人家 model 就是我们自己一层一层 build 起来的，然后这是一些经典模型，然后 ensemble model 就是我们把这4个 model 进行一个 ensemble， 来做判定，这结果就100%的全部准确了。我感觉我讲的东西差不多了，你们还有啥问题没有？没有，觉得感觉
你有啥可以用machine learning和人工智能要解决的问题问一下高中生？
其实还是蛮多的。
对，我说他们有什么？
对，
这个肯定是很多。
当时那个，我举一个早年的例子，很逗的，就当时呢，大概还是我刚刚接触这个东西的时候，然后当时我们说，那个悠悠这个数学题经常做错是吧？我们能做一个，把它的卷子每个都扫描一下，错的能自动识别，就是说有哪些就产生一个 pattern， 知道说哪一类题它能够识别，能错。然后当时是去做了这个东西，那里面那个识别的时候呢，因为印刷体的就很好识别，手写体的，就它因为那个卷子是个混合的，有印刷的有手写的。这个然后还有这个勾圈圈是不同颜色也有差别。当时是印象中这个手写体的识别就遇到了一些困难，然后就两个 combine 在一起就是遇到一些困难。但是这个就是现在我觉得很多那个智能的，就是说考试啊什么的，其实是可能他们一些机构就在做，就做这个。我像我说的，这个用这个客户这个叫啥学生，他做的题里面走错的是哪些，他可能就自动去做一些识别，然后再做一些推荐，说给你练啥题。就当时我是想做这样一个东西，但是没做出来。
这个可以做啊，这个。
对吧？
最近 MIT 用人工智能让他 watch 那个叫什么呢 ？Minecraft watch 到75万个 hour， 说训练出的机器人比人都打 Minecraft 厉害。他那个不知道怎么搞的。
对，大家也可以讨论一下，没啥问题，我们就可以自由互动了，就结束了。我这个讲的比我想象的还是快一些的，主要这个 library 我觉得这个是也许就是因为当时我们去做这些事儿，你可能人家只给你一个 sample， 然后就给你留个题留个问题，你回去得自己去做一遍，然后也不能完全 follow 它这个，你就得自己这样才能掌握。我觉得这个这么短时间让大家去搞清楚这些又没有练习，其实是很难的，所以。
大部分陌生人都是 Python 嘛，就是那个靠 library。
对，其实是 Python 的支持是最多的，然后还有一些 R 的，那个。
统计学的。
对，因为你想这个就是大部分开始做这些东西的人，他并不见得是 coding 特别强的，他就是属于专门做 model 的那种数学方面的。
可以把手喝的。
可以，觉得太冷了是吧？我吃不能打开，那你吃完冷和一点。我觉得我其实不知道这个就是后面这个是啥安排。我原来是觉得这么讲一节是一点意义都没有，就是根本就不能讲。
我都学了好多东西。
你学到了，但孩子可能听完就听完了。
没从头回去自己学。是回去你看到这个 slides 就自己去搜索了，你做什么项目就只能看。
对，我是
师傅领进门，修行在个。
现在还没有
还没有 concept 这个，没有 concept。
就是需要你逐渐的去搜索去。
Not really yet.
你看，我
Like
是
not completely
我
yet. I
是
need to
支
get
持
some
的，
money.
就说这我列的都是一些经典的教程。这个教程你看都是一个个 lab， 你走下去，你就跟着它的 code 走。
看到。
像我
马上让你。
对这个我的 link 在里面有，就在这儿，这一页我觉得是很有用的。
什么时候利用假期学一遍？
对。大家其实可以做一些东西的，就是下一步我也不知道啥安排了，反正跟我也没关系了。我觉得是必须要做上手的，就是而且这个算法我根本都没有 cover 实际的这个东西。
多谢，
谢谢。
没有，
我已经看到
希望了，已经看到希望了。这将来毕业找不着工作了。
你就你学这个东西学2年，不用去上大学就能找到工作了。
学孩子们还没有感觉是吧？
他们一定要上手，
他们还
找一个 project。
我也是觉得这样，因为我自己是明白的，就听过，基本上因为一下子。因为我每一个东西当时可能都是1节课，而不是说你这么泛的说一下。
需要动手，我们就领进门，修行在个人。
必须这样的，必须要做一点，而且也不能是完全有一个 notebook 直接跟，这样也是就是如果不去想，你 copy paste 一下，
他们对我儿子就是个经常 copy paste 的。
啊，真的有没有？就是玩练习，对，你们得自己去想。
好，谢谢。
或者说，对大家有问题可以找我。啥需要问的，或者是我不知道你们他啥安排，后面大家是不是要做抽奖？我在想，大家11年级还有，或者下学期还有时间吗？有时间可以做，没时间我估计。Senior project，OK。
对啊，可以啊，Senior project 可以。Senior project，你要这个是你的没你的导师。
我可以找更专业的人。
直接找你可以。
对，就是我感觉就是说学了，然后现在我们就日常遇到他们做的一些东西，就是还是会有些体会。因为我服务的就主要是这个算术，所以基本上但是因为我们还要做一些，比如说给他们做 model explanation 的那个平台啊啥的，所以其实会接触到很多算法，还是就是大体知道，而是细节方面。但是我感觉现在很多时候没法实现，博士们
对啊，这个就是数学 expert。
因为他们高中都应该学的，我们只能告诉你啊，你所有东西都在有用的。比如说linear algebra 之类的，
用的很多的。
Okay, never mind.